Regular Expression Bootcamp in Python. In this bootcamp, you will need a couple of materials. You will need Anaconda installed, scraping.txt file that is available on Canvas, and also Regular Expressions Python Jupyter Notebook that, if you wish, you can follow along or just review after the workshop. For Anaconda installation, please consult materials that were shared with you throughout the virtual classroom, but we'll also review a couple of important steps. When you start Anaconda application, you simply launch the notebook and you just need to navigate to the right folder. What I'd like you to consider is to organize your files in the folder as to represent your data analytical workflow, where you have a folder for data, folder for code, folder for key figures, and other possible folders. When you start your new notebook, unless you're using already existing, you just simply create new and select Python 3. If you're using different Python version, it will be shown here as, for example, Python 2. But be aware that the syntax is slightly different between Python 2 and Python 3. When it's open, it will be untitled. I suggest you to change title right away by going through to File, Rename, and give some meaningful name to your notebook that will be in your folder. Let's review a notebook structure. And of course, please check materials that were shared with you in Virtual Classroom 1. But to remember is that the most important is plus, add new cell sign, scissors, delete cells, and be cautious of deleting. Consider reviewing it first. Then you can always move cell up and down based on your workflow changes. Then you execute your cells. And another important place where to define whether you're using code, Python code, or you're using Markdown. So here that where you select what type of syntax to use. First, I suggest to give a title to your notebook and switch from code to Markdown. Add also your name and date and purpose. I would say metadata to identify your report, your document. Don't forget to run it, but make sure again this is a Markdown, because otherwise the syntax will not be appropriate for code. And if you still not sure about Markdown syntax, review it again from Virtual Classroom, but remember it has different tags to represent, for instance, whether it's a header or whether it's inline code, etc. So when I run my first cell, and this is the first cell, it looks like this. It outputted my metadata properly. I just had a little bit of information about myself, date, and objective of creating this specific report. So since the main goal of this workshop is regular expression, we should review regular expression syntax. So we need to define a couple of things, such as class, range, repetition. So let's start with class. To specify character, specify specific certain class, we'll use brackets. And within the brackets, we identify whether what items to match. For instance, if you place A, B, C, you will match A or B or C. 1, 2, 3, similarly, will match 1 or 2 or 3. Now we can define range. So instead of just specific list of characters, we would defining a range. For instance, from A to Z, all the letters, small letters from A to Z, and you can guess if you have A capital dash Z capital, it will match all capital letters from A to Z. We can also define numbers through the range, simply from 0 to 9. Using just one item is not sufficient. A lot of times we need more than one, and there are several operators that serve this need. So we have asterisks that will match 0 or more items. For instance, the same class range from A to Z with asterisks will actually match 0 or more characters, infinite number of characters in your data source. Then we can use plus that will match only 1 or more. In this case, if we have 0, it will not find this pattern. This is an example of A through Z with plus sign. So for instance, the pattern that can be matched would be A, AA, etc. Question mark is matching 0, 1. In this case, when we need to restrict our search pattern. When we have, for instance, A capital question mark, that means A in this case is optional. And think of when you're looking for certain name spelling, in some cases you may find a letter that is optional. So this is where you would use the question mark. With curly brackets, we can specify exactly how many repetition, or we can identify the range of those repetition. In this case, we have from 1 till 3. We could actually limit to what portion of our pattern will be returned. By return, we mean here to print. So if you enclose with those parentheses one of the patterns, in this case right in the middle, it will print this pattern. It will find everything you need, but it will print out just a portion of it. So if you look at this example, so we're looking for something that has at the beginning any number from 0 to infinite number of characters, small letters. Then we have one number between 0 and 9, then another number between 0 and 9, and we have another set of match that will be categorized by a small letter from A to Z. So for instance, it can pull this pattern ABC 12Z, but it will print only 12. So let's say if we're looking for date, to find dates in a string. And this is the explanation of the pattern. More special meta characters are used also to help us build our patterns. We already talked about parentheses, grouping, square brackets, identifying classes, whether it's a character, whether it's a number. We have curly brackets, range, specific number of repetition. We have this question mark, optional, right? We have plus 1 or more, asterisk 0 or more. Now we have this dot, wild card, that match any one character. In this case, it can be numeric, non-numeric, it can be any character in the string. The caret match whatever we are looking for at the beginning of the string, while $sign will match it at the end of the string. So we also have this pipe, which means or. If we have this condition, A or B, it will match A or B, but not both at the same time. And we have escape character, in case if we actually looking for $sign in its real meaning, not as a meta character, we need to help it escape by placing this escape backslash. Other useful shortcuts: instead of constantly defining a range from A to Z or 0 to 9, we can actually use this notation, small d, \d, any digit. So it is equivalent to our 0 to 9. Capital D with a backslash matches any non-digital character. It's like opposite. Then we have a small s, any white space. Capital S, any non-white space. Small w, any alphanumeric character. And alphanumeric actually means letters, characters, and also numbers, and a punctuation symbol, for instance, that we're using. Then we have opposite is a capital W, any non-alphanumeric characters. Regular expressions have certain methods based on the language. In Python, we would use module RE for regular expressions. And it comes with several functions. So we have compile pattern. That's where we create pattern and put it into object so that we can use later on. And here's an example of creating my pattern with specific pattern inside here. And then we can request or pull this pattern later on by repeating it here and searching inside the string. Then we use match function that can match our pattern in our string. And here's an example of, for instance, matching any word non-white space characters of as many of one or more. So we have two with a space between them, and the result of this would be, you can guess, they'll pull Isaac Newton with a space, but not the second string. So you can always print entire match or just part of the match. And since this is enclosed in parentheses, if you recall, you can actually define whether you want to print the first part and the second part, and that can be useful, for instance, if you need to split now first and last name. Split, another useful function that allow you to work closely with your strings, for instance, in your data, in your input, where you can split by spaces, by punctuation, etc. Sub is another useful function that will let you substitute, first find a pattern, then replace by another pattern. And find all will find all the pattern matching patterns.